Hello, everyone. Welcome to one more KieLive session. And today we have a new topic that how to test our constraint streams that we'll talk in a second. But first, I want to welcome all of you from the community to join this session. And hello, Karina. How are you?
I don't have any voice today, Perchetti. But I'm
Yeah.
feeling good, and I'm as usual, very excited for today's session because, as we know, unit testing is something that is like a must in every software, and you should test your constraints in OptaPlanner solutions too. So I think this is a great topic and on the right moment because as we could see, and there are a couple of videos on YouTube and blog, and also a new blog post. OptaPlanner is helping in like the most critical scenario we have today, which is the pandemic. So OptaPlanner is helping on addressing the use case where we need to assign to help planning the COVID vaccination schedule. So how can we develop these sort of things if we can't even test it right? So critical.
Yes. And by the way, I love your t-shirt. It's a vintage now. That's super cool.
It's vintage. Look, the
Yeah,
old
I
gentleman.
noticed that. That's awesome. I have mine upstairs. That from time to time I wear that. That's cool.
Perfect. And by the way, the guy that is going to talk to us today, Alex, he's a core engineer on the OptaPlanner team. So who's better than that to share this? And he's been in the Kiwi career, so he knows better than anyone how to test stuff.
Exactly. Today our guest is Lukas. He has been around in our business in our community for about 12 years, a little bit more. So I have memories from him from like the day I started. He was very tough with me back in the days, but it was for the great good. And as you mentioned, he has a good background on QE side. And today he will present a testing and will give a bigger overview or a bigger understanding of the impact of the good testing. So without more, I will bring in Lukas.
Hello, everyone. Thank you for the wonderful introduction. I just want to apologize for not showing up in person. Unfortunately, I got pink eye, so I look like a demon from hell. But other than that, everything's fine, and I'm excited about giving this talk.
Awesome. Lukas, don't worry. You got the pink eye. I don't have any voice. Today the KieLive is going to be in a different style, right?
Yeah. Now just don't ask me to do floss dancing or anything else to entertain the audience.
Awesome. So, Lukas, can you just give like a quick introduction on what we can expect for the talk today? Are you going to show the codes or just give some best tips?
Right. So it's going to be sort of a quick talk. I timed it to be about 25 minutes, so it's not going to be too hard. I'm going to be showing some basic concepts of the ConstraintVerifier API in OptaPlanner. I'm going to be showing how to test some basic constraints. There may be some tips, some tricks in there as well. There will be no live coding because I'm not good at that. Technology doesn't like me when I'm live coding. So there's going to be code examples, but I'm sorry, no live coding from me.
Okay, don't worry.
As long as we can see some code and some tips on testing, we're going to be fine. I'm quite sure.
Exactly,
Yeah,
especially if we can later reference to any examples that you might have, like Git repos that those are also useful.
Yeah, there's going to be plenty of links in the presentation, so don't worry about it. There are places I could refer people to.
Awesome. So, Porchetti, should we get started?
I think so. So I can't wait to see how to test my constraint streams.
All right, so let's get into this.
Lukas, before you start, just one thing.
Yeah.
For those who are watching, if it's your first time here, just know that we are always open to questions. Just drop your question on the chat. We'll be here on the backstage looking at it, and we will share it with Lukas if needed, okay? Okay, so now you can start, Lukas. Stage is yours. Bye-bye.
Thank you. Thank you. So as has already been said, I have spent much of my career in quality engineering. I've been doing testing. I've been managing testers. I've been doing all that stuff. So I do know a little bit about testing as well. And today we are going to be talking about testing constraint streams and ensuring correctness of OptaPlanner constraints. So this talk is going to require some prior knowledge on constraint streams. So if you have no idea what those are, please maybe come back to this video later and take a look at the video I'm pointing at right now, which is my own talk about all things constraint streams, basically an introduction. So once you understand that, please come back to this video, to this KieLive session, and you will get much more out of it. Now, since that video came out, sometime in September, plenty of things have actually happened, not just in OptaPlanner, but also around the world. So let me give you a quick summary of what those things are. First of all, in November of last year, we finally released OptaPlanner 8, which is our latest and greatest release. There are many good things about that release. I'm just going to name a few. First of all, we finally brought the XSD, the XML schema for solver config. So you no longer have to type solver configs out from documentation or from memory. You can just have your IDE do auto-completion for you. We have finally came up with the proper full integration with Quarkus and Kajito. So you can try all of those. So you can try that anytime you like. And we also have new quick starts to actually show you how to do that. So there's a quick start for Quarkus use for OptaPlanner. There's a quick start for Kotlin use even. So again, feel free to check those out. There's going to be some links at the end of the talk. And one more thing I should mention is that OptaPlanner 8 is nearly fully backwards compatible. I mean, unless you're doing some really crazy stuff, you should be able to migrate without any issues. Essentially, it's just changing the names of a couple of interfaces, and that's it. So if you haven't upgraded to OptaPlanner 8 yet, I recommend you to do so, because all of the great new stuff is going to be landing right there. Speaking of the great new stuff, one thing we have been doing lately is we have been working on vaccination appointment scheduling. I'm sure you've noticed what's been going on in the world for the past year. So the vaccination appointment scheduling is currently in the form of a quick start, and that quick start does allow you to schedule appointments for vaccinations. It can do all the different kinds of vaccines. It can keep track of the periods between the first shot and the second shot. It can schedule people, for example, for families to come together to the vaccination and all that kind of interesting stuff. So if you're interested in that, please check out the blog or watch the video we did on the vaccination appointment scheduling. And if you perhaps have some contacts in hospitals or in governments, maybe they would be interested in this as well, because we have had some really good results with planning a lot of people, a lot of patients for this. So if you're interested in that, please try that out. And that's it for the intro. It's time we moved on to testing constraints. So why do we test constraints? I mean, the reason is the same as for testing everything. You want to make sure that you're delivering the right thing, and you want to make sure that the right thing keeps being the right thing for years to come through years and years of maintenance, right? So first of all, you test constraints and software for correctness, which is, does it do what I want? You also test your constraints and your software for stability. Meaning, does it still do what I want even after I've made these 5 more comments? Some people also like to use testing or the tests as a design tool in the test-driven development methodology, where you first write your tests and then you design your software so that the tests do what, so that the tests actually pass. So those would be the three primary reasons for why I would say you would want to test your constraints, and they are, in my opinion, they are not too different from reasons for testing software in general. So with that in mind, let's take a look at the ConstraintVerifier API. So the ConstraintVerifier API has been part of the OptaPlanner Constraint Streams for probably over a year now. It integrates well with your favorite testing framework, be it JUnit or TestNG. Actually, you won't even notice it's there. It's just, you just use the API and it works. The code snippet I have right here. Is how you get to use the API. You actually have to introduce the OptaPlanner test artifact into your project. You give it a scope test because that's where you want it, and then you can start using the API itself. So the starting point for the API is a class called ConstraintVerifier, and when you call a static method build on it, the API will just start unfolding for you because it's a fluent API. So just type away, use the IDE auto-completion, and you should be able to explore the API without any issues. One thing I should mention, here you can see that I'm suggesting you should use OptaPlanner 8.3.0.final. This is currently the last version, but some of the features I'm going to be showing today are actually fresh off the presses. They've been merged like 2 weeks ago. So some of these features I'm going to be showing are only going to be available in 8.4.0, but don't despair, we will be releasing 8.4 pretty soon. So you should be able to play with these things pretty soon. So moving on. This is a sample constraint that we will be testing throughout this presentation. So it's nothing fancy. It does implement the constraint provider interface as all the constraints need to. It only provides one constraint in a method called unused computer, and then the constraint is implemented here as a constraint stream. So let's see what it does. First, it lists all the it takes all the computers. It selects the computers. It filters the computers so that you only get those that are currently running. So the computers that are turned off will not be included. It makes sure there is no process that would be running on the particular computer. And if there is no process on a running computer, it means that the computer is wasted. It is just sitting there. It's not doing any work. So it's just costing you money. So therefore, we penalize a computer that is running and that has no process on it. We use a constraint weight of 1 hard because wasting computers is not something that you want to do. And we use a match weight of the computer cost. So if a computer costs 1 unit and you only have 1 computer that is running without any processes, the final penalty of this constraint will be 1 hard. So hard score of 1 hard, 0 soft. Keep that in mind, this computer cost, because we will get to it a bit later. So now that we understand our constraint, let's take a look at the first simple test for this constraint. So you can see we have this class called sample constraint provider test. It's a plain test, nothing fancy. This test annotation is a test annotation from JUnit, but it doesn't really matter. It could be TestNG, it could be anything else. There are two more important things there. First, this is how you instantiate the constraint verifier. You call the class and the method I already spoke about, and you give it a couple things. First, you give it an instance of your constraint provider. That was the class I've shown you previously. You also give it a class of your solution and a class of your planning entities. Now in Quarkus, we will pretty soon be able to abstract that away. So you will be able to just inject constraint verifier without all this boilerplate. But right now, this is how you have to instantiate the constraint verifier into this class field, into this instance field. And then you can just use the variable in your test code. So this right here is a test method, which is called penalizes wasted computer. And it does a very simple thing. First of all, it creates a computer with a cost of 1, which is running. Therefore, we call it a running computer with 1 cost. It's just data object, nothing more. And then we call the constraint verifier method verify that, which gets an argument, and the argument is the constraint. So in our case, it's the unused computer. So this method right here in the constraint, that is what we give to the verify that call. So we say, hey, constraint verifier, just verify that my constraint unused computer penalizes when given this computer. So the constraint verifier will take the constraint. It will give it as input this one computer, and it will make sure that the end result of that is a penalty. It doesn't care what penalty it is, if it's hard, if it's soft, if there's 2, if there's 5, it doesn't care. It will just check that there is some sort of a penalty. So if we run this test, sure enough, we get a green check mark, because indeed the running computer has no processes, and therefore the test should pass, because the constraint will penalize that one computer. So now, what happens when it fails? So let's try an experiment. So instead of making the computer running, we set the computer as not running. It's stopped, right? So the constraint only penalizes those computers which are running. So right now, this penalizes call, still the same penalizes call, should fail. And indeed, it does. So this is an assertion error, which is the error that JUnit or TestNG or AssertJ or anything throws at you whenever a test fails. And there are some helpful things in the assertion error message. So first, it tells you that there is a broken expectation, which means that you didn't get what you were expecting. Then it tells you the constraint which failed, and the constraint is a wasted computer. It's the only constraint we have. You've seen that previously. And the reason why the constraint, why the expectation is broken, is because we expected a penalty, but there was none. So, I mean, either the constraint doesn't work or the test is wrong. You decide that. In our case, the test was wrong. But anyway, the final thing you can expect in the exception message is the explanation of the score. This time, however, there is no score, so there is no explanation. If there was an explanation, you would be able to see which objects, which justifications and indictments were actually in the working memory when it failed. So you would be able to better understand what actually happened with the scoring. So the exception message, I think, is pretty simple. So let's move on to checking your failures in a way that's more granular. So I mean, the penalizes call from before it just checked whether something penalized. But it didn't give you the option of checking how many times it penalized or what was the score when penalizing. So that's what some of the next calls we're going to be talking about are for. We have the same running computer, same cost of 1. Here you can see it's still running. We have the same constraint verifier call. We have the same given. We just changed penalizes to penalizes 1. So now we're saying we expect that the result of the constraint should be 1 penalty. And because we've just given it the 1 computer, there will really only be 1 penalty. Therefore, green check marks. That's what we like to see. Now, it may not be good enough to see if to see just the 1 penalty, right? It's not enough to know that something failed. You would like to understand what failed. So for that, we actually write a test that's a bit more complex. So we keep our first computer in the test, cost 1, and it's running. But we also add a second computer with a cost 2 that is still running. And we also add a process on that second computer. So the second computer does have a process attached. That means it is not wasted. So it will not be penalized by the constraint we've seen, because the constraint we've seen only penalizes computers that are running without processes. So how do we distinguish that in the constraint verifier? Take a look that the call of constraint verifier actually changed slightly. We still call the verify that on the same constraint. This didn't change, but we do something else in the given call. We actually give it more data. So we give it the first computer, we give it the second computer, and we give it the process, so that the constraint stream has all the data it needs to evaluate this new situation. And we say penalizes once. So technically, this didn't change much because we still don't know which of these computers actually caused the penalty. So let's take a look at another call. We switch the penalizes once by penalizes by 1, which is something different now. So I ask you to remember from the constraint that we use a match weight in the penalty of the computer cost. So a computer, so the first computer will penalize by 1, and the second computer will penalize by 2. So now we check that there was a penalty by 1, which means that this computer was penalized and not this computer. So by using penalizes by, you get to distinguish which things actually penalized and the value of the penalty. So not only do you know that it was this this computer which caused the penalty, but you also know that the penalty was of size 1, which is also an important information when you want to guarantee the stability of your scoring function. So the penalizes by call does use a match weight, so the computer cost. It doesn't use the constraint weight, which is the actual score representation. The reason why we don't do that in this particular call is because the constraint weights, they are configurable. You can specify them from the outside via settings, via dynamic configuration. So we only check the thing that is static, that is actually hard-coded, and we ignore the constraint weight, which comes from the outside. But you might want to say that the constraint weight is also pretty important, and I do agree. So here's what you do to include that in your deliberations. So this is actually a different test, which does something very, very different. So it reads the solution from a file. So imagine you have your solution serialized as an XML or as JSON or as literally any other type of file or any other string, and you read it into the test. And now you do something with the constraint verifier which we haven't seen before. So instead of giving it a constraint to verify, we give it nothing. So we say just verify that. And in the next step, we say, given this solution that you've just read, make sure that the score is a hard score of 1 and a soft score of 10. So what's this for? This is for integration testing. You already know when you've implemented your whole constraint provider, you have your whole solution ready. You want to make sure that your scoring remains stable for all eternity, right? So that's what you do. You store a sample solution file, which you know what the score is because you've calculated it before. So you know that the score is expected to be 1 and 10. And then you write a test that makes sure that given this solution, the score indeed is 1 and 10. So you now get to test both the dynamic constraint weight and the match weight over all the constraints there are in that constraint provider. So when this method finally passes, you know that you have a complete, well-integrated constraint provider that does what you expect it to do. And as I already said, this is going to be a fairly quick presentation, so I'm already at closing thoughts. You should be aware of the fact that all the penalize methods, so penalizes, penalizes by, etc., they also have their reward counterparts. So when you call reward in your constraint instead of a penalty, you get to switch the penalizes for rewards, etc. One thing that I probably should mention is that the constraint verifier is very good for making sure that the constraints are functionally complete, that they are implemented in the way that you want them implemented, but the constraint verifier API is not very useful for performance testing. In order to do all of the things that it does to explain the score, to check for the impacts and all that kind of stuff, it does actually bring a lot of overhead. And if you were to measure those pieces of code that I just gave you, you would be actually measuring more of the constraint verifier API and less of those constraints themselves. So for testing, for performance testing of constraints, you would have to deploy different methods. Most likely would have to involve the solver, but that's not really the point of this discussion. Also, as I already said, some of these features I've just shown will only be available in OptaPlanner 8.4, but that's literally just around the corner, so no need to worry, you will be able to play with them pretty soon. But the API itself has been there for many months. So even if you start with OptaPlanner 8.3 right now, you will still be able to get a lot of use from the constraint verifier API. And finally, this is where you find out more. So we have fairly comprehensive documentation. You can also check us out on GitHub, where all the source code is. You can ask a question on Stack Overflow. We are there pretty frequently. We answer questions. And of course, if you have any questions or if you want to chat about a particular problem that's been bothering you with OptaPlanner, please join us in the community on the Zulip chat. And we gather there. We talk there every day. So that's where you can find not just me, but the entirety of the OptaPlanner development and QE and docs teams and essentially everyone. So that's it from me. And I'm looking forward to your questions. Please.
Awesome. Great presentation, Lukas.
Yeah, and I have one question, Lukas.
Go ahead.
Are we shipping our getting started examples that we have with such testing example as well?
Yes. So if you go to the URL here,
Okay.
this is the core repo for OptaPlanner, and then there is a module called OptaPlanner examples, OptaPlanner examples, and all of those examples, or rather, most of those examples currently have constraint providers, and every example which has a constraint provider also has a complete constraint provider test. So that is a large library of inspiration, I would say.
Awesome.
This is great. This is really great. Lukas, I will ask you to please share the slide deck with me so that I can share with the folks who follow us. And for those who follow us, we have our slide decks here on this speaker deck from Key Community. And this slide deck will be there still today. So if you want to take a look at the examples, at the links that he shared, you'll be able to find it there, okay? So, Lukas, thank you so much for your participation. I really enjoyed the way we can test our constraints is pretty easy, not just to write, but also to read and know what's going on there. It's pretty intuitive. So thanks for sharing it.
Yeah, it was very clarifying. It was, honestly, it was a new feature to me, and it's very clear how to get most of testing and how to interact with this API. Very clear. Thank you very much.
You're welcome. I mean, of course, it was a design goal to make this as easy as possible. So yes, we are glad that we did manage to do that.
Awesome. So, Lukas, thank you for your participation, and looking forward for upcoming talks from you, maybe this year still. Let's see. Have a great day, Lukas.
Thank you. Hopefully next time with the camera and without the pink eye. Well, let's see.
Yes, yes, please.
Not a bad idea.
And, please feel better soon, okay? We should feel better soon.
Yeah.
Thank you.
Bye.
And for you in our community that is still around here with us, next week we have a special guest. And this guest comes from the community, from you. Is not this particular presenter next week is not a Red Hat employee. Is someone that is contributing and using the key technology in his needs. And this is also a good way to invite all of you of this community to submit your presentation to KieLive and be here with us to present what the goods that you are having with the portfolio that we have.
Yeah, I'm looking forward for Kim Jong's session because he's using Druze as his core rules engine, and I want to see what he could achieve with it. Let's see.
Yeah. And with that being said, today we have a short but very helpful session. And thank you very much for your time, and see you next week. Oh, just before, don't forget to subscribe, to like, and I don't know, all the whistles and bells there that YouTube will help us to collect feedback. You'll be notified when new content will be available.
Yeah, and if you have any content that you would like us to bring, just drop in the comments and we will make sure that we plan the session for you, okay? Have a great day. Bye-bye.
Okay, bye-bye.